is Hryhoriy Vashchuk, and this is a video made to show the functionality for the software part of the full unit project, which was made on the topic of the Travelling Salesman Heuristics. So first of all, I want to mention that the whole project was made in Java, and the graphical user interface was made with JavaFX. So in order to run the program, we need to run the app runner class, which opens a graphical user interface for us. And on the first page, user is able to see user is able to choose how to create a matrix for the input. So it either could be the matrix from a file, or it could be a randomly generated matrix, and the user could be able to put the dimension size for this matrix, which should not exceed 100 or be less than 1. So for example, here you can see that if I enter 101, then it gives me a warning. So if we go with 15, for example, we go next. So this is the second page, where user is able to see the matrix that was generated. As you can see, all the elements are random. So on the next page, this is a so-called algorithm page, where user could see all the heuristics that were implemented in this project and run each of them, as well as to see the detailed information about them. So for example, nearest neighbor, which was the nearest neighbor, and we press the run button, it gives us the elapsed time from the start of execution and until the resulting route was formed. And it also provides us with the information about the pass cost. So here you can see a button with the see details. So if we press this button, we have a created file, txt file with the corresponding name to the heuristic. And in this file, user is able to see once again the matrix that was used as an input and the city to city pass. So these vertices are actually cities, and the cost is the distance between them. And as you can see, the first city is 6 and the last city is 6, as well as all the other cities are only visited once, hence the Hamiltonian cycle was formed. Here, users are also able to see once again the total pass cost for this route made by the nearest neighbor, and the time elapsed in milliseconds as well as in seconds. So let us close this. The same functionality is provided for the repetitive nearest neighbor. As you can see here, the time lapse, the pass cost, and the new txt file, which was made for the repetitive. And the same thing was made for greedy or vertex insertion and to-opt. So it's important to mention that for greedy, here in the city to city pass, user is able to see that they were made like as an edges. So the source is actually 4 and the destination is 12, while weight is 3. So here weight means the distance between cities 4 and 12. And as you can see, once again, the Hamiltonian cycle was formed, and there is a total pass cost and the time in milliseconds and seconds, as well as the input matrix that was used in this case. And for the to-opt heuristic, this is actually a to-opt plus nearest neighbor, which is an optimization for the nearest neighbor. So if we press the see details, we can see that the nearest neighbor pass cost was 2,858, and after the optimization it became 2,247. So yeah, once again you can see the Hamiltonian cycle was formed and the information about the pass cost and the time, as well as the input matrix. So on the last page of the graphical user interface, user is able to see the heuristics efficiency in comparison. So this is a graph, line chart graph, which shows us the times elapsed for each heuristic. And I would also like to mention that all of these matrices with dimensions 30, 60, 90, and so on up to 300 consists of randomly generated elements. So in some cases, for example, here you can see greedy on 210 is better than on 180. That is because of the randomly generated elements. And users also able to see the pass costs on the same matrices. And here's the pass cost for each heuristic. Yeah, so users able to compare them, and the detailed comparison made by author me was made in the final report. So yeah, this is all about the functionality of the software part for the full unit project on the topic of Travelling Salesman Heuristics. Thank you for your time.